In this lesson, we'll look under the hood of our queries and see how execution differs between running locally in DuckDB and in the cloud with MotherDuck. We'll start with a simple query counting complaints per year. Using explain, DuckDB shows us the plan. First scanning the table, then calculating the year, grouping and counting, and finally sorting the results. When we switch to explain analyze, DuckDB actually runs the query and gives us runtime stats. We can see how many rows flow through each step and how much time each operator takes. Now, here's the interesting part. When we run the same query in MotherDuck, the plan includes extra steps for cloud execution. Those are the hybrid operators. They handle running parts of the query in the cloud and streaming results back down. And it's not just about reading plans, it's also about improving queries. For example, in our case, the way we calculate the year turned out to be expensive. By switching to a simpler expression that extracts the year directly, we cut down the projection costs dramatically. The runtime stats make that visible immediately, and the difference is clear both locally and in the cloud. By the end of this lesson, you'll know how to read query plans, compare local versus cloud execution, and spot easily optimizations that make your queries faster and cheaper. Alright, what I have created for you is on the left here, this is where I attached the sample data database, and on the right, I just basically loaded our elevator data DuckDB database. Now, on the GitHub again, you'll find these statements. On the left, what we're going to do here, or on the right, we're going to just put in and explain, and then have our select statement that actually counts the elevator requests by year, right? And on the left, we're going to do the exact same thing, but we're just going to do this with the sample data. So this runs the explain and basically creates the plan in the cloud. Let's look at the plans. When we compare here, in the beginning, everything looks the same, right? We have a scan on the cloud for service requests. It projects here a lot of rows. We have a scan on the local one. Then the projection, same thing as you can see, 22,504. We had that before when we did the counts. Then it's doing a group by and showing us the rows, and then it's doing an order by. Okay, but what happens after that? When we look after the order by here, the right plan is done because that's where we receive the results. But what this does is, because this runs in the cloud, right? It actually needs to then send us the data, and those are these two here. Batch download sync, that means it's downloading the data here from us or to us, and this is actually looking from our side, okay, we're downloading it from the source. And this bridge ID basically shows where the data is coming from. And that is the physical plan here. Now this was just the plan. Let's explain, analyze, let's actually execute it. Boom, explain, analyze. And then we're doing the same thing here as well. Now when we do the actual execution, we see this is basically the same table scan, projection. Then we have a group by, then we have an order by, but then this actually changes, because after the order by locally, then we have the explain, analyze, and that's it. Everything's done. But here on the cloud, we then have these extensions. And these extensions are basically what we've seen already with the batch download sync and download source. It's basically the same type, but then we have the hybrid runner, and that is kind of an orchestration in the cloud, right? That then starts off these two extensions and then downloads us the results. Then we have the explain, analyze, and that hybrid stats collector actually is something locally that then asks the cloud, give me some stats about the data. So we can see here, again, total runtime, 0.877 seconds for us, but a lot of time here with the table scans, with the projection and so on. So how could we actually optimize this left part here? Where we're losing the most time is here in the beginning, right, with the table scan, because of the projections, how we create that created date. Remember, we were using here in the query strf time for the created date as year. This is something that we can make better easily. So let's change this and let's execute this again. So what I've done is I've changed this to select extract year from created date as year. And when we look at this now, this, instead of 5 something seconds, this only takes 3 seconds 20. Right? It's still a sequential scan, but how we create that created date is now optimized. And now it takes less time to actually create this. And then we end up with 0.367 seconds. Before we were 0.7 something, right? So this is an easy way how you can use that explain analyze to find out what's exactly happening, and also find parts where you can optimize your code. And we're going to see that next when we look at a union where we basically query both databases together.